Greetings, college trigonometry students. Today in this first part of the video, I'm going to do section 6.3, just looking at classifying triangles. So this will be pretty simple, just a lot of vocabulary in the section. So first of all, if you classify by sides, there's three possibilities. You could have all sides equal or congruent. That symbol you may know from geometry means congruent. It just means the measure of the sides are equal. So the equilateral, three congruent sides, isosceles. Now, a lot of times, technically, isosceles is at least two sides are congruent. So technically, an equilateral triangle is a type of isosceles triangle. And then you have a scalene, which has all different sides. No sides are congruent. Okay. You can also do this by angles. We have an acute triangle. It just means that all three of the angles in a triangle are less than 90 degrees. We have a right triangle, which just means one of the angles is 90 degrees. And then we have an obtuse triangle, where just one of the angles is above 90 degrees. So those are some of your possibilities on that. So here's kind of a little applet. I'm always kind of on the internet looking for applets and stuff to kind of show you this idea. So let's see what this thing is here. So, you look at a scalene triangle. This is a scalene triangle because all the sides are different. It's an acute triangle because all of the angles are less than 90 degrees. Okay, so you can move this around, and then if you make two of the sides equal, like I'm trying to do here, unsuccessfully, okay, there we go, okay, 6.7. So on an isosceles triangle, you have at least two sides are equal. This is an acute triangle because all three angles are less than 90 degrees. One thing I want you to notice on this isosceles triangle, since you have two congruent sides, notice that the opposite angles to those sides are also congruent. So that's kind of a well-known geometric property. I could shrink this. It's still isosceles. There we go. Isosceles. So notice that the angles on the bottom, called the base angles, are the same. Okay. If I wanted to drag this over a little more, then I've created a obtuse triangle because one of the angles is greater than 90 degrees. It's scalene because everything is different. All the sides are different. And then if I wanted to make that a 90-degree angle, then I've got a right triangle. And if I wanted to move this side down like that, now I've got an isosceles, and that was trying to make out, there we go, an isosceles right triangle like that. So this is kind of a little applet that shows you how you can manipulate the sides and the angles. Okay, so I'll go back to where I was, and then we're going to do just kind of an activity where we classify some angles and stuff. Okay, so another thing that I want to show you is the sum of all angles in any triangle is 180 degrees. What this diagram is attempting to show you is you could take these three angles represented by alpha, beta, and gamma, and they would make a straight line. There's a couple of cool applets that I want to open up to show you this, and this is kind of a cool one right here. So the idea, this would be a equiangular triangle. All of the angles are equal to each other, and it turns out that they all would make a straight line. Okay, if I move this over like this and make this into an obtuse triangle, again, if you put all of these angles together, they're always going to make 180 degrees. No matter how you make this triangle, it's always going to be that way. So that's kind of a cool applet to kind of mess around with and show you how all those angles go. Okay, another one that I found that was kind of cool was this one. And let's see, with this one, here we go. Kind of another good way to do with this is all these three angles are going to add up. So I could move these angles just kind of like this. I can move that angle there, and then I can move that angle there, and then you see that all three of those angles add up to 180 degrees. Okay, I could do that for different triangles. No matter how I change those angles, they're still going to add up to 180 degrees. And this is kind of a cool applet because I can manipulate the angles. If I want to move the angles, it's just showing you that if I take the other two angles, I can make that into a straight line. Therefore, all of the angles add up to 180. So that's a cool little visual to show students then. Okay, a couple of things I want to just mention in this diagram right here is this. This angle right here, these two right here, they are congruent angles. And that's because they're called alternate interior angles. If you have two parallel lines, then these would be what we call alternate interior angles, and they're congruent. Also, this angle gamma and that are alternate interior angles. The way this works is if you have two parallel lines and you cut it with what we call a transversal, then these things on alternate sides of that transversal will always be congruent. So this is actually kind of how you can understand why all three triangles add up to 180. We already know that this is a straight line, so it's 180 degrees. This angle's equal to that, and then the blue angle, one I have highlighted in blue, is the same as that, so they have to be able to make a straight line. Okay, so let's do a little classification exercise here. So to begin with this, we're just going to look at, these are the possibilities. So the first one, first of all the sides are different, so that would be a scalene triangle. Since it's scalene, that would mean all of these angles, and it's not because it's scalene, it's just you can see that all of these angles are less than 90 degrees, so that would also be an acute triangle. Okay, the next one, all the angles are equal, so we call that equiangular. And there's a kind of a well-known geometric idea that's very logical. If the angles are all congruent, then the sides have to be equal. So this would also be an equilateral triangle. And it would technically be isosceles. And again, if you go on the internet and look around, sometimes you'll see people defining isosceles as two sides are congruent, and that's not really correct. It's at least two sides are congruent. So an equilateral triangle is also isosceles. Okay, the next one is, again, sides are different, so that would be scalene. All of the angles are less than 90, so that would also be an acute triangle. Okay, next page. All right. This one right here is, again, equilateral. All of the sides are equal. And again, if the sides are equal, then these all have to be 60-degree angles. So one way to look at that is all of the angles add up to 180 in a triangle. So if you divide 180 by 3, you get 60 degrees. So this would also be equiangular. And then also, again, you would also have an isosceles triangle as well. Okay, all right, so at least two sides are equal, so it's isosceles. Okay, the next one you would have, it's acute. All of the angles are less than 90 degrees. And then if these two angles are equal, then the opposite sides are equal. So that would also be an isosceles triangle. Okay, next one, it looks like you have a obtuse angle. So this would be an obtuse triangle. And as far as the sides, even though I didn't give you what the sides are, it's easy to realize that since all of these angles are different, then all of the opposite sides would also have to be different. So that would be a scalene triangle like that. Okay. Okay, down to the next one here. Just trying to give you as many scenarios as possible. This one, again, is an obtuse, has an obtuse angle. The most a triangle can have is one obtuse angle. The other two would always have to be acute. Okay, this one also, you have two equal angles, so that means the sides opposite 40 would be congruent sides. So you have two equal sides, so that would tell us that this is an isosceles triangle as well. Okay, next one, all the angles are different. They're all less than 90, so that's an acute triangle. Since all of the angles are different, all of the sides have to be different as well, so that would be a scalene triangle. Okay, Next one, all the sides are different. So again, that would be scalene. And you can tell by looking, all of these angles are less than 90 degrees. So that would be an acute triangle also. Okay, then the last things on here, this one again, all the sides are different. So that's scalene. And it looks like you do have one obtuse angle that's bigger than 90. So that would also be an obtuse triangle. So it's an obtuse scalene triangle. Number 11, it's equilateral. Again, if it's equilateral, all the angles have to be equal to 60. All the sides are equal. So this would also be equiangular. It's the only triangle that can be equiangular is an equilateral triangle. And also it would be isosceles because at least two sides are congruent. Okay, and finally the last one, you've got an obtuse. You have one obtuse angle. That angle's bigger than 90. You have two equal angles, meaning that the opposite sides are congruent. So this one would also be isosceles. Okay, so that's an activity just kind of getting you familiar with the vocabulary of parts of a triangle. They're either, if you classify by side, scalene, or it could be isosceles, or it could be equilateral. If you classify it by angle, it could be acute, obtuse, or right. Those are the possibilities. Okay, and that will wrap up this very short video. Hope this helps you with your vocabulary.